Hey everybody, welcome to the lab. Now that we've done all of our calculations, we know what we would expect the final product to be for each of the 4 possible reactions. Now we're going to actually carry out the investigation to find out what does happen when we put 2.5 grams of baking soda into our little crucible dish and we decompose it using heat. What is the mass of the final product? And so the first thing we have to do is figure out the mass of our crucible. Now, perhaps you've read a play called The Crucible. A crucible is where things get cooked and get heated and get super intense. And that's what this little dish right here is going to do in our experiment. So when it's empty, it weighs 28.2 grams. At least this one does. Sometimes they're metal. But this one weighs 28.2 grams. And then we're gonna add exactly, hopefully, 2.5 grams of baking soda to it. Okay, so we wanna add exactly 2.5. I'm gonna zero the balance, and then I'm gonna try to add exactly 2.5 grams of our sodium bicarbonate, also known as baking soda, to it. Maybe a little too much. Oh no, that's perfect. Okay, so we added 2.5 grams plus the 28.2 that was already there is 30.7, okay? So plus those two together, and if I take off the 0, oh no, it won't tell me that. If I 0 it here, and now put this on, that should confirm 30.6. Okay, there is a little bit of error in the balance, and you can talk about that. It's possible, oh, there goes, 30.7, that it could be off by like 1/10 of a gram, but this one looks good. So what we're gonna do now is I'm gonna set up the Bunsen burner, and we are going to heat the crucible, just like the setup here, for 10 minutes. I won't make you watch all that, don't worry. And when we come back, we will check the final mass and see which mass that we calculated is that closest to. All right, I'll see you in a couple. All right, folks, we've set up our Bunsen burner just like in the diagram. And now we're gonna go ahead and put our crucible with 2.5 grams of baking soda and the lid, just so that if there are any particles that move out, the gas can still escape, that's fine, but if there's any solid matter, it'll be trapped in there, okay? So we'll go ahead and put our crucible on the Bunsen burner, and we're gonna allow it to heat for 10 minutes so that the sodium bicarbonate, the solid baking soda, can fully decompose, transform into a new solid product. We'll meet back in 10 minutes to take its mass and try to figure out what it is, okay? See you then. Okay, so we let our crucible go for 10 minutes. It's fully decomposed, hopefully now. I'm gonna turn off the gas and just let this cool for a second. And now what we're gonna do is we're gonna take the mass of our final product. First, let's take off the lid and take a look at it and see what it looks like in there. So it's still a white solid, which makes sense, but I can see some like crusting and crisping around the edges. It looks a little less fluffy, so maybe some gas has escaped, was heated to the point of escaping. And now I'm just gonna pick this little crucible up, and we're gonna put it over here on the balance, which is zeroed right now, and we'll see what it reads. Okay, so the total mass of our final product that's in here and the crucible together is 29.8, okay, grams. So we'll go ahead and write that down, 29.8 grams. And then what we wanna know is just what is the mass of the final product. So you're gonna see this again tomorrow on your stoichiometry quiz, or when you take it soon. And you're gonna have to think about, how do I calculate just the mass of the final product? If this is the crucible, this is the dish and the white solid, I need to subtract away the mass of the dish, of the crucible. Take that away from this, and then I'll know just how much that white stuff, that product weighs, okay? So to do that, I'm gonna do 29.8, the mass of both of these things together, and subtract away the mass of the dish, which is what we have here. That was what we took at the very first thing. What's the mass of the empty crucible by itself? So 29.8 minus 28.2 gives me 1.6 grams. Okay, so that is an answer then that I am going to go back to my calculations, which you calculated in your packet, 4 different calculations. Which number is closest to 1.6? Which reaction? Is it 1, 2, 3, or 4 gives you the closest thing to 1.6? And then you can write up a little lab report and say, in this investigation, we heated baking soda until it decomposed and chemically transformed into a different compound. We started with 2.5 grams of the reactant. Our observed mass of the final product was, what was it? 1.6 grams, and that is closest to the expected mass of blank grams from possible reaction number blank, okay? So you have to pick, is this 1, 2, 3, or 4? Which reaction, and how much did you expect? That will let you know what you think the product is. Is it sodium hydroxide, sodium oxide, sodium carbonate, or sodium hydride? Then you can tell them how you ruled out the other 3. If you think it's reaction 1, how did you rule out 2, 3, and 4? Because the expected mass of those was not even close to what we observed. Our observed mass and our expected mass are not exactly the same. The math is perfect, but the science is like real life. It's not exactly theoretical. It's not the exact theory. They differ by blank grams. That's going to be a very small number because I think we are very close to what we calculated. Is what we got lighter or heavier? And then why do you think so? Okay. You can see the scoring rubric at the bottom. Just do your best, and you'll be able to use all of this that you've done on tomorrow or on our stoichiometry quiz. Okay, so the more you can do today, the more notes you can write down, the better that will go. And that one's all tasks, okay? All right, great work, everybody. See you again soon.